Now that we have spent the last couple lessons talking about how to represent situations with equations or expressions using both numbers and variables, we're going to start looking at what a solution to one of those equations would be. Now, you guys have done some solutions in the past when you're solving equations. You've learned that in your previous work in algebra. So this is going to build upon that, but also need us to recall some of those solving skills that we've had. And so we'll talk about those as we go through. All right, our situations today regarding solutions are going to be in the context of a few different types of problems. The first one is related to some nutrition. So a granola bite contains 27 calories. So visualize that granola bite. Maybe you have granola for breakfast. Most of the calories come from grams of carbohydrates. The rest come from other ingredients. 1 gram of carbohydrates contains 4 calories. The equation 4c plus 5 equals 27 represents the relationship between these quantities. What could the 5 represent in the situation? Okay, so if you recall maybe from nutrition class or maybe just something that you have learned about in the past, that calories are essentially the energy that you're getting in food, and that's what fuels you during the day. You need calories in order to have energy to do things like math assignments or run or play an instrument or do anything really. Even while you are just sitting and breathing, you are burning calories. So calories come from a variety of sources, and we're saying, okay, so carbohydrates is one source of calories, and 1 gram of carbohydrates contains 4 calories. But calories also come from other sources, and so that's discussed here. The rest comes from other ingredients in the granola bite. And so really, that's what the 5 is going to represent. The 5 represents calories from other ingredients in the granola bite. All right, I just know a little bit about food and calories. It's something I probably should brush up on, but I know you can get calories from sugar, you can get calories from various sources. I think protein gives you calories too, but sugar is definitely one that I believe could be added to the carbohydrates to give you more calories. So Priya said that neither 8 nor 3 could be the solution to this equation. Explain why she is correct. All right, so if it is a solution, we should be able to plug in 8 or 3 into the equation for the calories for C, and it should work out to 27. All right, so let's see if that works out. So we're going to take this equation up here, and we're going to now put 8 in place of the C. So we take that 8, replace C with 8, so 4 times 8 plus 5. And let's see, what does that turn out to be? 4 times 8 is 32, and 32 plus 5 is 37. So did that come out to 27? No, it did not. All right, so that one didn't seem to work. Let's try the other one, 3. So if we put 3 in for the grams of carbohydrates, because each gram of carbohydrates is 4 calories, let's see what we come up with. 4 times 3 is 12. 12 plus 5 is 17. So also not 27. So neither 8 nor 3 gives us 27 calories as an answer. So Priya is correct. So what would be a solution then? So let's go ahead and look at the original equation. 4c plus 5 equals 27. That's our original equation. And so really we want to know what is the number that we can put in for C here that makes this statement true. Now you can start to do some trial and error, but as we go through our solving steps, this is when we're going to have to recall our solving steps. You may remember that I talked about the reverse of PEMDAS, which is SADMEP, can help us with remembering the order of operations for solving. Sometimes people have used the word GEMS for the order of operations. So GEMS stands for grouping, exponents, multiplication, subtraction. So I suppose you could think of the reverse of that, SMEG, as a way of ordering your solving operations as well. Or maybe you just think about, okay, I got to work my way back to the C, so I have to undo everything that's farthest away first and then work my way back to the variable and get it by itself. There's some different ways of doing that. We're going to start off though with the subtracting or adding, and we're going to undo that first. So we're going to undo the adding of 5 by subtracting 5, so balancing it on both sides of the equation. That cancels out the plus 5 on the left, so we have 4 times C left over on the left side, and 27 minus 5 would be 22. Then let's go ahead and undo now the multiplication or division. Multiplication and division are inverses of each other, so they undo each other. So we're going to undo that 4 times C by dividing both sides by 4. So when we do that, we end up with a 1C. 4 divided by 4 is 1. You could just write C there. If you don't want to write the 1C, you can just write C. And then 22 divided by 4 on the right side produces an answer of 5.5. So the solution is C equals 5.5. All right, so in other words, 5.5 grams of carbohydrates would work. Is a solution. All right, let's go on to the next problem. A little bit different situation here with weekend earnings. Jada has time on the weekends to earn some money. A local bookstore is looking for someone to help sort books and will pay $12.20 an hour. To get to and from the bookstore on a workday, however, Jada would have to spend $7.15 on bus fare. Write an equation that represents Jada's take-home earnings in dollars, E, if she works at the bookstore for H hours a day. So there's a couple of pieces here. She is going to earn $12.20 per hour, so there's that H, but she's going to have to pay, she's going to have to spend money on bus fare. So that's going to be subtracted off the amount of money she gets to get her total earnings. So let's think about that. So she earns $12.20 per hour, so times the number of hours. But then she has to subtract off her $7.15 of bus fare, and then that will give us her total earnings. So now, in number 2, one day Jada takes home $90.45 after working H hours and after paying the bus fare. Write an equation to represent that. So if you notice, we have now $90.45 that are her earnings. So let's put that into the equation. So 12.20 times H minus the $7.15 of bus fare turns out to be $90.45 of take-home pay. So now that would be the equation with that amount in for her earnings. And the next question is 4 a solution to the last equation? What about 7? So think back to what we were doing on the first page. Let's see if we have solutions. So we're going to explain our answer of how we know one or both of them are solutions, and if not, we're going to be prepared to explain why they're not solutions. Then find the solution. So let's put in 4, see what happens. So if we put 4 in for H, because 4 is the amount of hours then, so 12.20 times 4 minus $7.15 what does that turn out to be? Right? Does it come out to $90.45? So maybe I'll write that up here. Does it equal $90.45? So if we put that in to our calculator, maybe 12.20 times 4 minus $7.15, we get $41.65. So not a solution. Remember, we were looking for $90.45, not $41.65. Let's see if 7 is a solution. So now we'll put that into the equation. Run our calculations. 12.20 times 7 minus $7.15. That comes out to $78.25. So also not a solution, because it didn't equal the $90.45 that we wanted. So if we're going to find the solution, we're going to need to figure out how we can solve this. Actually, I'm going to keep the same color for now. All right, we're going to take our original equation then, and we're going to go ahead, actually, we're going to use the second version of that equation because we know we're going to equal $90.45. Let's see what we get. So we have 12.20h minus $7.15. We want that to come out to $90.45. So we want to know the number of hours that gives us $90.45. So here's where we're going to go through our solving steps again. So first step is to undo any subtracting or adding by doing the inverse. So we're going to add $7.15 to both sides to undo the subtracting. So that gives us $12.20 times the number of hours equals $97.60 if we add that. All right, we're running out of space here, but we'll just do the best we can with it. So 12.20 times h, so to undo multiplication, to get the h by itself, we're going to divide both sides. All right, so that gives us the 1h, or just h left over on the left side. And $97.60 divided by 12.20 actually comes out to exactly 8. So h equals 8 is our solution. So in this situation, what does the solution of the equation tell us? So Jada needs to work 8 hours to earn that $90.45. So back up here in our equation, we're wanting to know, what number of hours which you have to work to get that $90.45, and we just worked backwards and solved it and said, all right, she would have to work 8 hours. 12.20 times 8 minus 7.15 equals $90.45. So I like the little extension problem here down at the bottom, so we're going to talk about that as well. So Jada has a second option to earn money. She could help some neighbors with errands and computer work for $11 an hour. After reconsidering her schedule, Jada realizes that she has about 9 hours available to work one day of the weekend. Which option should she choose, sorting books at the bookstore or helping her neighbors? Well, the first calculation is pretty straightforward because she works 9 hours for her neighbor at $11 an hour. So 9 times $11 per hour gives her $99. So that would be there's the bell. That would be the computer work, right? And the other one would be, if we just take the equation as it is, so 12.20, that's the one we were working with, times 9 hours minus her bus fare. So if we do that calculation, that turns out to be $102.65. So this is the book one. All right, so which one's better? Well, if you take a look at the straight numbers here, it looks like the bookstore is just a little bit better. Not much, but $3.65. So you could argue that that is the better one, that she should take that one. But if you think about it more, you might come up with some reasons why the computer would be better. For one, it's more convenient. So although it's slightly less money, for a big difference, that might be one thing, but slightly less money, and it's much more convenient. Secondly, you could maybe even argue that the 9 hours really isn't how much she'll have at the bookstore, because if she only has 9 hours available, well, she's got to take the bus to the bookstore. And so will this number really be 9 by the time she gets to the bookstore, or will it be 8 hours? Or will it be something in between? We don't know for sure, but reasoning through, if she only has 9 hours, there's some interpretation here that that number would actually be less than 9 hours when she actually got to the bookstore and started working. So the computer might be better in that situation. I'll let you decide how you want to interpret that, but those are a few ideas. All right, third problem. What should we use here? Let's go blue. 1 gram of protein contains 4 calories. 1 gram of fat contains 9 calories. A snack has 60 calories from both the protein, P, and F grams of fat. The equation 4P plus 9F equals 60 represents the relationship between these variables. Determine if each pair of values could be the number of grams of protein and fat in the snack. Be prepared to explain your reasoning. All right, so we got grams of protein, and then we have grams of fat containing 9 calories. All right, so we've got these two different things, and we know that they should add up to 60 total calories. So hopefully now this is starting to kind of click in here. If we're given numbers for the variables, to find out if they work, we need to put them into the equation and see what we get. So let's go ahead and put 5 in for the grams of protein, so 4 times 5 plus 9 times the 2 grams of fat, so we're going to put 2 in for F and see what we come up with. So 20, 4 times 5 is 20, plus 9 times 2, 18, so that would turn out to be 38. All right, so 38 calories. All right. It does not equal 60, so it does not work. Recall that our equation up here, the grams of protein and fat need to eventually work out to give us 60 total calories. In this case, it was 38, so that didn't work. All right, let's try the next one. Let's put 10.5 in for P. So 4 times 10.5 plus 9 times 2 for grams of fat. See what that turns out to be. So that would be, let's see, 4 times 10.5 is 42 plus 18. So that turns out to be 60 calories. So that does equal 60. So works. So that would be a solution right here to our situation. 10.5 grams of protein and 2 grams of fat does give us that amount of calories. Let's try the third one, part C. So if we put in 8 grams of protein and 4 grams of fat, that'd be 32 plus 36, which would give us 68 calories. It does not equal 60, so does not work. Okay, so number 2 now says if there are 6 grams of fat in the snack, how many grams of protein are there? Show your reasoning. So in this case, we're given one variable, and we're going to have to figure out what the other one is. So recall that what we have here is an equation 4P plus 9F equals 60. This time, you're given 6 grams of fat, but not the grams of protein. So let's put that in and see what we get. So 4p plus 9 times 6 equals 60. And so now we're going to actually go through our solving steps here. Actually, let's simplify this just a little bit more first before we start undoing from both sides. So 4p plus 9 times 6 would be 54 equals 60. All right, so now let's use our solving steps. We're going to undo addition by subtracting from both sides. That gives us 4p equals 6. And then 4 times p, to undo multiplication, we are going to divide. So 4 divided by 4 gives us just p, or 1p. 6 divided by 4 is 1.5. So p equals 1.5. And remember, that is grams protein. So we just came up with another solution here. 6 grams of fat and 1.5 grams of protein gives us 60, so that would be a combination that works, and therefore that would be a solution. So in this situation, what does the solution to the equation tell us? Give us an example. So we just talked about that a couple times. It's essentially the protein and the fat that works, that gives us a total of 60. So a solution tells us the grams of protein and fat that give a total, that add up to a total of 60 calories. There are multiple solutions to this. We talked about the two above that I've starred. Can we come up with another solution? So this could be a little trial and error. You could plug numbers in for p and f and see if you can get 60 as a result. You could put one number in for either p or f and then solve for the other one. A nice solution, after a little bit of thinking here, actually turns out to be 6 and 4. All right, so 6 grams of protein would be 24 here, and 4 grams of fat, so 9 times 4 would be 36, so 24 plus 36 turns out to be 60. So 6 grams protein and 4 grams fat make the equation equal 60 calories. In other words, 4 times 6 plus the 9 times the 4 equals 60. So that is yet another solution. See if you can find even another one that would work. There are multiple combinations that would work. So now we've talked about our equations and representing our equations, but we also have talked about what a solution to an equation is and how we can interpret that within a contextual, a real life situation.